Today we're looking at lesson 5.3. We're continuing to find the inverses of equations. However, we're going to be looking at exponentials today. So exponentials, we want to be able to define the term logarithm as the inverse of an exponential function, and then be able to define and justify domain restrictions on exponential and logarithmic functions. So we know that addition and subtraction are inverses, multiplication and division are inverses, squaring and square rooting are inverses. So today we're going to look at, if we have an exponential, what is the inverse of that? So we're going to start by looking at f of x equals 2 to the x. So we have our standard exponential here. We should know this parent graph from back in our transformations unit. So if we have 2 to the x and we want to graph that function, we could plug in a bunch of different values. If we were to plug in -1, we plug in -1. 2 to the negative first is 1/2. If we plug in 0, anything to the 0 power is 1. If we plug in 1, 2 to the first power is 2. So if we were to plot these 3 points, we could have our sketch of our exponential 2 to the x. So if at -1 I'm at 1/2, at 0 I'm at 1, and at 1 I'm at 2, I can sketch my exponential. Remember, I'm coming towards my asymptote there at 0. So we'll get really close, but never cross. So if I want to find the inverse of 2 to the x, I know I just switch my x and y values. So if I were to switch -1 and 1/2, I'd have 1/2 -1. If I switch 0 and 1, I have 1, 0. And if I switch 1 and 2, I have 2, 1. So if I were to plot these points, I would be graphing my inverse. So if I'm at 1/2 -1, I have my first point, 1, 0, and 2, 1. So if I were to sketch this, I have my inverse. And I can see that if I had my line of reflection at y equals x, it does in fact just reflect right over this line here. Each of these points is reflected over our line of reflection. So we want to see, if we have an exponential, well, what is this inverse here of our exponential? And the inverse of an exponential is called a logarithm. So like I said before, we have addition, subtraction are inverses, multiplication, division, square root, square, cube root, cube. So we now have an exponential and what we're going to call a log. And we're going to see how these two forms go back and forth and how we can use them to solve. So logarithmic versus exponential form. Really, a log is just a number. It's a way to solve for an exponent in an exponential. So if we're missing our exponent, we can change it into a log to be able to solve for our missing value. So to go from one method to the other, you can kind of think of it as loop and swoop or down and around. So if we had 8 equals 2 to the third or 2 to the third equals 8, we would just go log base 2 of 8 equals 3. Down and around, loop and swoop. So it would be log base 2 of 8 equals 3. And we can see that these two are equal. Log base 2 of 8 equals 3 is the same thing as 2 to the third equals 8. Down and around. So if we go down and around, we have 2 to the third equals 8. We see that they're equal, and we're just going all the way up and around in that order is going to give us one form to the other. So we're going to start off just writing each of the following in their alternate form. So if we're given a log, write it as an exponential. If you're given an exponential, write it as a log. So for example, what I'd like you to do is I'd like you to copy these down and go ahead and try and write it in its alternate form. Okay, so if we're given log base 5 of 25 equals 2, we want to write that as an exponential. So we always start with our base. If it's the base of our log, it's the base of our exponential. So we would have 5 to the second power equals 25. 5 to the second power equals 25. The base of our exponential is the base of our log. We went down and around. 5 to the second power is 25. So if we're given an exponential of 3 to the third power equals 27, and we wanted to write that as a log, we would go down and around. The base of our exponential becomes the base of our log. So it would be log base 3 of 27 equals 3. Because our log helps us solve for the exponent. So it's always going to be equal to the exponent. So this would be going log to exponential and exponential to log, just rewriting the two forms. So example 2, we're starting to lead into being able to find inverses. So it says rewrite an exponential form and find the missing value. So now we have an x value that we want to be able to find. So if we're given one form to solve, we need to go to the other. So my base is 6, so I start with 6, so it would be 6 squared equals x. So I have 6 squared equals x, down and around. So I know what 6 squared is, so I know what x is. So x equals 36. So if I were to look at the second example, I have a base of 3, so 3 to the x equals 27. So 3 to the x equals 27. So I want to think 3 to what power equals 27? Well, 3 to the first is 3. 3 squared is 9. 3 to the third is 27. So x would have to be 3. So I can change from one form to the next in order to figure out what x is. So I went from a log to an exponential to figure out what x is. So my ultimate goal is to be able to write the equation as an inverse. So I have an exponential and I have a log. So I want to write these equations and their inverses. So if I start with y equals 3 to the x minus 5. Well, we know that inverses is just switching our x and y value. So that's going to be our first step here. I'm going to take my y and my x and I'm going to switch them. So if I rewrite this, I have x equals 3 to the y minus 5. Remember, my ultimate goal is to get y by itself, so I need to solve for y. If I want to solve for an exponent, I have to do the inverse. And remember, we just learned the inverse of an exponential is a log. So I want to take this and I want to turn it into a log. So to do that, I want to take my base and I want to go down and around. So I would have, I'm going from an exponential to a log, so I have log base 3 of x equals y minus 5. So what I would have log base 3 of x equals y minus 5, and now I want to solve for y, so I'm going to add over 5. So I have log base 3 of x plus 5 equals y. So our original equation is y equals 3 to the x minus 5. We have an exponential. So its inverse is going to be a log, and its inverse is log base 3 of x plus 5. So then if we were to look at a log wanting to find the inverse, we know that our inverse should be an exponential. So we're going to start by switching x and y. So when we switch x and y, we get x is equal to log base 2 of y plus 1. So since y plus 1 is in parentheses, we need to change it to an exponential first. So to change this to an exponential, we start with our base and we go down and around. So we would have 2 to the x equals y plus 1. So then to get y by itself, we would subtract 1. So we get 2 to the x minus 1 equals y. So we have our original function as a log, so our inverse equation is going to be an exponential. So we can always graph and look at a table to confirm that we do in fact have the correct inverse equation.